Yeah, good morning everyone. Myself, Mr. Sankur Naresh. I'm an assistant professor in Civil Engineering Department. Today I would like to discuss about the one of the important topic in our thought in it, that is incidence of the solar heat on buildings. It means the sun energy is going to be impact directly on buildings or structures. What kind of effects we had, then how we are going for a mitigation of these all those things. In this session we are going to be learn very clearly regarding all the parameters related to the this incidence of the solar heat on the buildings. So the first slide I want to go for it. If you look at here, there is an introduction section. See that here there is a what is a solar incidence. That means the effect of the solar radiation on buildings. At the same time, influence of indoor temperature and energy consumption, that is comes under a solar heat incidence. That means effects is included, and also there is a temperature and energy consumptions also is included here. So and also if you see here, there is a why it is important, because after building design and energy is efficiency, and then there is an impact of thermal components like HVAC systems performance. So likewise we are going to be have some importance, and also other than that, that it is receive certain stresses from the temperature, so it is also going to be affecting the durabilities of the building. Or otherwise if you not care about all those things, definitely we had any problems. There is any failures in a durability point of view. So likewise thermal stresses should be induced in that, and then induced thermal stresses is going to be creating additional stresses within the structure, and then it's going to be affecting the total lifespan of the building. So that's why what is happen, it is very important in the civil engineering point of view. Everybody should learn about how the efforts is going to be takes place, and at the same time how it is going to be takes control. Likewise we are going to be discuss. I will give one more example regarding why it is important, because every summer season we are going to be utilizing the ACs to make them come down the room temperature, or to make them lower down the room temperature up to maybe in a 20 degree or 22 degrees Celsius likewise. But if it is observing the more energy, if it is observing the more energy, definitely there will be a problem. Then it takes more electrical energies to make them room cool. So likewise the consumption of the power is also going to be more. If the power consumption is going to be more, means maybe it is creating a unsustainable development. So that's why we are giving the importance to this incidence of solar energy on the buildings, because we want to rectify it, or otherwise it will be become a huge problem. And one more thing I want to tell here, in the 2010 and 13 that range, the temperature levels are very less, but when compared to nowadays, because nowadays the temperature is maximum 58 or 56 degrees Celsius in Andhra and Telangana itself, but in the previously maybe the 38 and 40 or 42 is a maximum. That means the global climate changes is going to be takes place. That's why we are giving the more important to because it is affecting the structures. So likewise we are giving the importance for this one. And the next one, if you see here, next slide, there is a solar radiation and its component, and then there is a direct radiation. That means sunlight is reaches to the surface without any scattered, and then diffuse solar radiation, that means scattered light from the atmosphere, and then reflected solar radiation, light reflection from the ground and nearer by the surfaces, and total solar radiation, sum of all the components of affecting the building. That means if you see here in the first one, that energy is going to be impact on that that means acted directly on the buildings. And then something that means diffused solar radiation is nothing but something is can be hold with maybe clouds are there in between sun and a building. Maybe the clouds are there, that means there is a diffused solar radiation is going to be act on, and reflected solar energy radiation, that means after reaches to other materials, the sun energy, it is going to be reflected and reaches to the buildings again. Likewise, there is a three types of radiations is going to be affected on the building. So and then if you see that there will be any factors affecting the solar heat gain. So if you see here, there is a geological geographical locations and latitude and climate conditions. And next one is a building orientation, that means the direction of walls and windows, and time of the day and session changes the sun angle and intensity. That surface material and color observe the reflectivity and glazing and windows design, the type of the glass and shadowing the devices. So these are the factors which is affecting the solar heat gain. I want to explain with an example so that everybody can understand easily. So if you see that there is a latitude and climate conditions. So for example, latitude, that location, because you are very nearer to maybe desert areas, then automatically that solar effect is very more, because the reflective energy is going to be getting from that nearby, that it's very high. But in the similarly, you are nearer to very water bodies, that heat energy is absorbed by the buildings are very less, because it is can be not going to be reflected, it can be absorbed by the same material. Then climate conditions, for example, it is having the high temperature condition, it is can be taking that there will be a more energy on it. And then if it is in a low temperature, maybe rainy season, you have a low temperature effect is going to be there at that moment, because of cloud formation and all those things, because sun is not going to be changed, but the climate in our atmosphere is going to be changes, because if any clouds are is going to be held, and then more precipitations are existed. Likewise, there will be a rainy season, you got a less effort is going to be takes place. The building orientation, what is happen if it is in north direction, or if it is in a south direction. So in the case of the south direction, that more ventilation is going to be there. If you open the doors and windows in the south direction, directly the sun energy is going to be entered into the inside of the room. And similarly, if it is in a east direction also, the similarly sun is going to be entered directly into the homes. And at the same time, the direction maybe east and south direction is having a problem regarding. And then next one is what are the material we are going to be using. So and we are going to be utilizing the materials, and then these materials we are have some steel material if you have taken into the consideration to construct it. And then there isn't a problem with that, it is observing the more heat, and automatically that indoor and outdoor temperature is going to be changes. And then surface material and color. So for example, that everybody tell us don't wear the black shirt at mid daytime, because it is observing that there will be more heat. If it is in a white color, then it is observing the less heat, because it is reflecting one. So likewise here, what is happen that is there in the dark in nature, it is consuming the more sun energy, and then if it is in a white, it is taking the less energy consumption. And then the glazing also, even if you want to use any wooden doors instead of glazing doors, that temperature effect is very less, because it is holding certain amount of energy. But if you are instead of this wooden, if you are using any glazed glasses as an windows and doors, then definitely that energy is going to be released. So likewise, what is happen, material we are going to be using, and then based on the locations, and based on the orientation, and based on the season, and also that it is going to be affecting the solar heat gain. So likewise, we need to discuss about that what are the ways are there it is affecting. Now if you observe here, there is a solar heat gain through windows. Solar heat gains in the coefficient measures how much the solar radiation is passing through the window. And effect of the window orientation, the south face windows and receiving the maximum heat in the winter, and in east and west facing windows experience high heat gain summer, and north facing windows receiving the minimum direction radiation. So that we had some directions. Previously we discussing that the same thing here also, clear given in the very clearly here. Then the next one is the thermal mass. That heavy material is absorbing the releasing the heat slowly, and then installation to reduce the heat transformation and improve the energy efficiently. A roof reflectance, lighter colored roofs reflect more heat, and the roof and cooling roof reduces heat absorption and improve the indoor comfort. So likewise, a passive design strategies to the control of solar heat gain, that proper building orientation is needed. That means optimized sunlight is exposure, and then shading the devices outer hang and lower and vegetation, high performance glazing like low E coating and tinted glasses we are going to be using instead of the glazed glasses. Thermal installation reducing the unwanted heat and temperature, and it can be transferred. And next one is ventilation and airflow, natural cooling technique. So likewise you have an strategies are there. And the next one is an active design strategies. The solar control films reduce the heat and glaze, and energy efficient windows glazed, double glazed and insulated frames. So likewise you have a smart faded and adapted shading, automatic blinds are existed, and HVAC optimization, the smart thermostat and efficient cooling systems. And the next one is urban heat island effect. Higher temperature cities due to the concrete and asphalt surfaces impact on the buildings and increasing the cooling demand, and there is a discomfort. Mitigation strategies, a green roof we need to provide over there, and reflecting surface we are going to be applied, and then urban vegetation we are going to be implemented over the trees. So likewise you have a feasibilities are there. So and then if you see here, there will be a, yeah, solar heat gain in the urban areas. So that urban heat island, higher temperature in the cities due to the concrete and then asphalt surface, that impact on the buildings increases the cooling and demand and discomfort. And the mitigation strategies, the green roof and reflective surfaces and the urban vegetation. So if you are providing in a green roof, like roof is made with a structural steel structural only, but it is covered with that any green leaf materials, and then it is reflected surface and urban vegetation. So likewise we are going to be discuss all those things. And if you see here that case study and energy efficient buildings. So for example, a modern office building with an optimized heat and control, and the south face windows is shading a device, and reflective roofing and insulation of the walls, a passive validation, ventilation and the thermal mass utilization. And the results, it means reducing the energy consumption and improve the thermal comfort. And then if you see that there will be a conclusion here. So to understand the solar heat incidence for the sustainable building designs, a properly planning and reducing the cooling loads and enhancing the energy efficiency, that incorporating the passive and active strategies leads to long term benefits. So it is very useful, so that you should understand the concept, and then after that you should learn about all those things. If you have any doubts regarding, I will clarify your doubts in the classroom itself, or otherwise you have any other doubts are there other than these, then you can ask me in the Google Meet. Likewise we are discussing all those things, but I want to give a short overview on the what is the topic I am discussing in the till now. The simple one, here the morning everybody seen there is a sun that is reflecting on the buildings, and then finally what is happen, it is going to be affecting the soil or building, because additional stresses will going to be created, it's in a problem. That's why they are going to be utilizing the another type of the methods to get that all those things. And thank you so much. If any doubts regarding, and then if you see that next slide also, there is in a now books I'm going to be utilizing for the referencing sake. Then you just any doubts you just put in a message so that I will reply. Thank you so much.